dw over dy has to be mp because dw is a gradient with the shape of w, and y is a oh
Should have the same shape as y.
no, okay, this is exactly what we're doing wrong. I figured it out. Y is a scalar, or it should be a scalar. It should be L. The
Yeah,
gradient of a gradient of a matrix multiplication where y is also a matrix is actually a 4D tensor, which we
yeah.
don't want. So actually, this shouldn't even be dw over dy. It should be dw over dl. And so um we should actually be thinking like
I think usually people want dl by dw.
yeah. So this is so we actually want dw over dl. We want to change how much does w change given a minor change in l, right?
Mm-hmm.
And then so over here it'll be x uh uh d w over dl. Whoops, d
That's the same.
no. Um I guess it would just be dy over dl, which makes sense. And then so dy over dl is mn. Then we have we cancel out. Actually, this it's all coming together now. And this is so dw over dl is mp because it has to be the same size as w.
W,
And then so we got to cancel out um to cancel out the
pn of x.
yeah. So we have one thing of mn and one of pn, and we need to get mp. So
Two
therefore,
transpose one.
yeah, so dy has to come first because we want that m to be first, dl. So and then we need to transpose this, and it should be xt, so that we can get the n's to cancel, and we get something of np, right? Because this is n, whoops, np. Sorry, I'm drawing on my mouse. This is horrible. And this is mn as we previously established. So the result of this is mp, which is what we want.
So dw by dy is x transpose,
Yeah.
not just x.
And
This is unsatisfying. I can work out these transposes, and I did in a different case as well by just doing the
it is
shape
so
analysis.
unsatisfying.
But there's something we're missing here that should
It's
make this automatic.
no, it just sucks. This is how I did it in the stupid class I took at UCLA too. It just
Mm,
sucks balls, unfortunately.
no,
Anyway, fish.
I don't know why the word fish is in here.
Les fish. You took French?
Yeah.
Why not Spanish?
Mm.
Okay, so dx over dl is a
That I think is just w.
no.
Let's see,
It can't be
shape of
w. You have
x.
to take the dy over dl into account somewhere. Otherwise, it doesn't make any sense. Right. this should be WT d y over dl, and that should give us what we want, because then we get WT is
Wait, where's L
E
though?
and
What is L? Just some scalar expression from Y.
yeah. I so maybe I should just put like and then F sorry, L is equal to, I don't know, F of Y, but it just it's the back prop. I don't know, just came from nowhere. This is M, and yeah, that's it. So this is about what I expected, actually. So I think that's right. There's also some nonsense about like denominator notation versus numerator notation, but I don't even remember the difference. It's been too long. Do you remember?
Numerator and denominator notation,
Oh, you don't remember this? It's so bad.
like in matrix
Yeah,
calculator.
yeah, exactly. Oh, layout.
Oh, right. Which
So,
one do we use? I think I went with the. Wait, never mind.
oh,
Think of something different. To switch for denominator, I guess. I think the numerator layout is better
um,
because vectors are usually written as column vectors.
I want, I don't know, but like, CS231N uses denominator layout, so I'm tempted to stick with it.
All right,
Okay, I guess I don't really know. I guess I won't worry about it for now, or something.
the annoying transposes.
Yeah, some nonsense like that. What did I do? Oh yeah, I just deleted some nonsense. I'll just also delete this. Look at how nice these things are. They're literally just some the most basic of definition. Anyway, Oh yeah, I forgot I deleted accidentally.
What did you delete?
Oh, no, I didn't delete. It got closed, so I need to re-navigate to the correct workspace.
Oh,
Yeah, here we are. Okay, so the input, d weight, weight, d out, and input.
which should be the same shapes as input and weight, or rather out. Nonetheless, those are the same. And this could be
I'm
you could
confused at how we have both the d input and d weights as inputs, whereas we're supposed to be producing them. I don't think this is right. I think we should delete these because
what's he keep.
I
Oh,
think the reason that why they're in is because inside C they're like pointers.
he probably keeps them for the rest of the chain rule to be multiplied against. Because I think that's all that would happen to them anyway in the inner expression. Because this is like, I think essentially a glorified version of multiplying the input by a combination of weight and out. Like, let's see, if it's the input prime. What is this matrix expression though?
I think we
Is it
should do things from first principles and then worry about like use
okay?
our logic and then worry about optimizing later because we don't even need it to be fast.
Okay, well, if we have weight and out, then the expression I'm assuming we have is y equals wx.
Hmm? Oh yeah, that's right. We don't need to worry about bias for now. We'll make our own thingy for
Yeah,
bias.
w can have shape, sure, OC to C to use this notation. Input is T by C. Wait, this can't even work already.
Something is screwed up here.
Oh, right. It's
The
probably,
transpose.
yeah.
See what I'm telling you? If you don't use if you use sorry, then you're losing out on the benefits.
That, but there was no sorry in that one.
I mean, no, that one was actually technically correct. If you transposed, if you like, it was just a transpose that was wrong.
Sure, but that is not from the sorries.
Yeah.
Also, even with the sorries, I actually have, if you hover on any of these individual terms, not the sorry, like the actual term being indexed,
Yeah. Vector, vector, float, C. COC.
but also just like the O itself. The
I'm
But it
gonna
needs to establish that O is within OC.
I'm gonna just make a copy of this and then
Sure. Okay, and this should be transposed
why is it giving me two errors?
because you're putting two doc comments.
Oh,
Delete that and that. You also can't just put doc comments on arbitrary things
really? I didn't know that.
because they're actually like syntactic elements.
Oh, interesting. I guess that makes sense. In my language, all the comments are like that. You can't put comments anywhere. You can put them in front of every expression. But
Like right here, I try to doc comment a regular comment,
Oh, interesting.
Unexpected element. And
Deep
then if I
here.
hover it, unexpected token, let expect. Oh, actually, it skipped the comment and thought I wanted to document this let block, which is nonetheless not allowed.
Gotcha.
These are some of the things I guess I can, which is a pretty big list, but not everything. Gladly, you can comment notation and document it. Unification hint. I didn't even know some of these existed. I didn't know about unif hint. Didn't know about tactic extension.
Interesting.
I knew about the simprocs from reading the compiler notes. Simple like
What the heck
tactic.
is a simproc?
Simplification procedure.
Hmm.
Oh, here's some for div and mod.
Oh, built-in dsimproc. Oh, interesting.
It's like a mini compiler pass. I think
That
Thylene uses it pretty extensively. Okay, so that
wait. So I'm just gonna do mn. Or sorry, m. Actually, I'm just gonna literally follow what I said over here because it's easier. So, inp,
you still left that as mm.
yeah, inp should be np. Wait, it's pn, so it should be pn. Reading from the Jesus, this is messing with my head.
Yeah.
And this is pm. Oh no, mp. Can you catch me if you see me making any errors?
I'm already trying to think this one through.
And this is uh nm, right? Okay, so
And
int,
that's n out would be n
yeah,
by
so
n.
it's pn reversed, uh as np reversed is pn, that's right. It's pm reversed mp, mn.
Shouldn't that be
Whoops.
nm?
Yeah, that should be nm. Thanks. Um, and then the out should be one instance of the d should be sorry dinp,
Uh,
one instance of dinp, which is
np should be int
yeah np, and one of
pm.
pm. Okay, and then so now all we have to do is just our matmul's. That's all we have to do. Like, we didn't actually
Yeah.
need to do any of these things. We could have just done um let in matmul
The derivative with respect to the input should be like d out times weight.
oh yeah, first let's define the transposes. First define transposes. Let in prime equals int dot transpose.
I wouldn't use prime in this case. Like,
Oh yeah, you're right.
yeah. Well, let me
Yeah,
try
it
that.
would be wait t d out.
Honestly, this is the one I would have just like hammered on it, and because the type checker would catch it.
Yeah. Okay, and matmul uh
D weight, uh, in t. Uh,
D out, um, and then in T. Wow, nice. Boom. Dude, I love dependent typing now. What the heck? Dependent typing is my best friend. Come on, don't lie to me.
I'm impressed. So yeah. I mean, I was such a believer in it that I wasn't even going to bother to figure out the correct order of multiplying things.
Believer in what?
That the dependent typing was
Oh,
made me. Like, as soon as this line was written, it's like, okay, so we're in endgame now.
yeah, exactly. Like, and also I was like, this is what I'm telling you. Like, why do this when you could do this? You know what I'm saying? There's certain benefits. You want me to? I'll just delete this unless you want to
Yeah,
look at it.
it's you can delete it.
Now we'll do the batched matmul.
It's like,
Oh well, do we even have a matmul batched?
yeah, I defined it.
Okay, then we don't even need this nonsense. Well, actually, no. Let's keep it. Let's keep it for posterity, I guess. But like,
Don't need what?
yeah, what I was gonna say is we don't need to like change it because this is already doing our work for us, the Lord's work. So we don't need to like worry about um
The matmul batched is.
yeah, we don't need to worry. I was gonna implement matmul backward in terms of like batched, but it's fine. We don't need to worry about it. It would have been the same like length anyway.
Yeah. This batched one, however, shouldn't this not have a B? It shouldn't be summed over for reduction, or you're just going to leave it unreduced.
Oh no, you're right. Um, wait, input. Well, I'm not sure. I think the weight should definitely be reduced, but I don't know about input. Should input be reduced? I don't think input should be reduced. I think just weight.
But these inputs could all be different because they're different batch ones. So it should not be reduced.
Yeah, that's what I think too.
Um,
Because our inputs are reduced. Sorry, our input should definitely not be reduced. To be honest, I'm not even sure I want to reduce. I want to do as much reduction as he because he's worried about like um efficiency, etc. But we're in lean, which is like a language that's going to be way slower than C anyway. So we may not even care that much. Like
what do we
yeah.
do for the encoder backward batched? That one we did reduce it. Yeah, see, because we do a sum at the end.
Yeah, but these are for weights, so that's fine, I guess. There's nothing about the D input because there's no D input because it's just like tokens, you know,
Mm.
versus for
Okay, we can leave it unreduced. Maybe put a note though.
yeah. Let's reduce the weight but not the input. Um,
There.
yeah,
Second one.
yeah. That's got it. Goaded.
Really, you're that easy. That's a little ugly. Just like at least make it look like dot sum sort of. Or dot zero. That's like, come on.
What do you mean?
The whole instead of the giant thing
Oh
vector.
yeah, no, dude. We could literally replace it with just 1 0. Like,
Yeah, then do it that. But like,
wait, what? I
I
can't.
think you have an extra paren.
Oh yeah. Oh my goodness, so much better.
And then you can replace that with a double dots for the plus.
What? A double dots for the.
Instead of like
Oh
this
yeah.
lambda thing. I like that idiom for simple stuff. Although it can very easily be.
Dot. Oh yeah. Plus.
Yeah. Backslash period will work too.
Oh nice.
Actually, in fact, I think you might have to use backslash period. I think that's a different dot, which could
That's
easily,
horrible.
yeah, could easily drive someone crazy.
I would kill myself. Okay. Yeah. No, that's beautiful. Exactly what the doctor ordered.
Okay,
Okay. Cool. So, I think we've cracked this nut. Let's would you say we move on to attention?
yeah, let's do attention.
Hit commit. Okay, so now I'm gonna pull up my code from last year. Which is just attention from Scratch and Python, and let's implement it by this one because it's very simple. Oh goodness. I'm just gonna kill all Firefox. I'm limited by the technology of my
You
time.
and Arjun both have kind of shitty computers.
Arjun just got a
Oh, he
MacBook
finally
Pro.
did it. Okay.
I'm gonna discard.
You should know that I like
Wait,
the
can't.
reason for that.
Oh, Apple should just pay you like a finder's fee, honestly.
Yeah. Nina and I just like well, it was hella rainy a few months ago. And Nina and I were just like going at him left and right, but just like get a better computer. Where he revealed his reason for not getting a better computer was basically purely stupid. And so
Oh no.
we, I told him
I actually don't think my computer's that bad. I just need to
I
get
tried to sell him this computer actually, but he said
nice.
that the marketing was too successful and he got a maxed out one, which was a good move. Although I don't know if he's actually gotten much benefit from it yet.
Okay. So I've got a little bit more RAM now. Reopen. I love RAM.
Just download the update. This is starting to bother me. Fine.
No, I can't download the update because it's like managed by it's not managed by VS Code. It's managed by my package manager. So it won't even work. It'll be like, oh, could not find update.
Oh, so it just bothers you
Yeah,
instead.
it's just there to annoy me, honestly. I should just like disable that.
If you hit Control B, it'll toggle the sidebar, which kind of helps. Never
Okay.
mind. I didn't get rid of the little strip. Wait, why do I not have the little strip then? What the hell?
I don't really care about the little strip, honestly. It doesn't really bother me.
Okay, attention head.
Okay, anyway, I'll actually zoom out a bit. I think I'm. Oh yeah. So anyway, the key thing to look at here is just q at k dot transpose -2 -1, which is just I think it's just k dot ht actually. Huh?
HT.
Okay, wait. So k is in batch size.
K in? What do you mean in?
Oh, what I mean is k is in r to the power of.
Fine, okay.
But that's just notation. I didn't know how you describe it. It's like k has dims.
You just write a colon. K colon that.
Yeah.
Okay. Mass attention, a batch, context, context.
Okay, so
Okay, so we make a bunch of 3 tensors and do some multiplying.
yeah, pretty much.
Okay, well, we might as well start with trill.
Ignore trill. We'll just feed in as an input to our model. Um, okay, so I'm gonna grab a snack actually.
Okay.
Move. Rest my brain.
I'm starting to really miss VMap.
This one.
VMap, the vectorizing map function. You didn't like the batch dimension thing because it's unnecessary. That's what VMap is for. It auto batches functions.
Oh yeah, it makes sense, I guess.
This guy's research notebook has a picture of a composition notebook.
Based.
Yeah, this one. Blah, blah, blah.
Wait, so where's VMAP?
This guy's start taking a sweet time to call it. There.
Oh, so it just creates a batch function out of a single function. Oh yes, that makes sense. And it like automatically vectorizes it so that it uses the correct vector output.
Yeah.
So that is cool.
And then because it's Python, they have to use partial, whereas we can just use real partial
Yeah,
application. The partial keyword is truly ugly too. That it's also like a long word for a concept that's supposed to be implicit.
I agree.
Then again, Python also deliberately made pattern matching into a statement and not an expression, so
You mean like let? I mean, sorry, let equals or match?
match.
Oh,
Python
yeah.
doesn't have let.
Sorry, I got confused. I meant like variable binding.
They made that from a statement into an expression as well with the Walrus operator, so the opposite.
So bad. Have you written a compiler?
Only like the basic Lisp stuff, not a full one.
I need a compiler right now. I get to make all these fun choices.
Have you been writing it throughout this week?
No, I've quit. I kind of stopped writing once I started working on this lean project because I don't have enough time to work on two side projects like this.
That's probably fine. This is also basically a compiler's project anyway.
One could view it that way, yeah.
One tries to view it that way because it's the problem solving technique.
Sorry, I'm just taking a break. You can start working if you want. I was gonna share it with you.
Thinking, where did I put all this extra junk?
What are you in Cupertino for?
Just visiting my dad for
Okay.
July 4th.
Nice. Same. You're from Cupertino originally?
Yeah,
Oh, nice. Which high school did you go to?
Monte Vista.
A classic. Oh my goodness.
Oh, this is where it all is. I also added some
Wait,
polynomials.
which year did you get? Which year did you graduate?
2013.
Jeez,
Yeah,
that's actually crazy. I did not realize you were that much older than me. I had this impression that you were like, I don't know, for some reason, like only 2 or 3 years older than me, but that just put things into perspective.
guess I look young.
Yeah. So you're 29.
Yeah. Wait, you do know that. I already told you that.
I just forgot about it.
Um, Oh, I found something interesting, which is also sometimes given hypothesis on loops, just by giving it a name, even if it's not used, it'll put it to scope and it will auto infer.
Oh, that's useful.
Although you have to name them, you can't just throw them away with an underscore.
What's this?
From the Levi-Civita field, but also defining some basic polynomials. Not
Nice. All right, I'm ready. Estoy listo. So yeah, so we have on D embed DK. Okay, if I just hit here, no. PC, um, yeah, output is something output. Oh, I get okay, so backside, um, uh, code, code. So can you put it in? Okay, that's what isn't it? Yeah, I know. But I figured how to the command you were doing it right. Oh, did you overload the dimension? Um, yeah, that's fine. We like we let on back the five we got that's still like the semi-pro. This is K. This X. That over. Oh, okay. Oh, oh. So all of these are doing that. All of these are DK. This is also would be hard to implement that, like, flat all the way down. That's what we need.
Instead of the dot, well, you do x dot map, and then the whole lambda y thing becomes just the dot divided by non-parenthetic in parentheses. But here, a small pair of parentheses.
Like this.
Yeah, get rid of the whole line.
Oh yeah, I guess it makes sense. Yeah. Now, yeah.
They're also to take the population six
Forward. The mask goes into the there has to be some way to
mass fill in this value if
I just need to add negative infinity to that. Like stuff that mask equals one second. Why not just add one second to everything? Negative, sorry. Like that will be the trick. And that way I don't need to have this mask fill operation. I can literally just make that full. And then in the places where it needs to be. Um, wow. There's no negative. Big.
I would generalize this more to just make a
Yeah, and then I get it. So, yeah, that's very deep. Zero out.
the default of alpha to say that
No, but yeah. Find out.
that's not obvious.
Look at that.
Right? Maybe
That's good.
yeah, already did the transpose. Too soft, not for too
It's soft. Yeah, it's soft.
You can just highlight with the dot. So
I can just
actually slightly implementation just because it goes straight to the underlying data type of the array unnecessarily. I mean, obviously, but it's not really any more efficient. Necessarily getting
with like using float here.
to sound. See how it does like array fold left and on vector fold.
Copy from me. I made that same mistake. Maybe Copilot did it earlier.
The dot data call.
Oh, yeah. The thing, but it's not.
Hover over this letter C right there, just on this horrible suspicion. Oh, because it goes over.
Yeah.
I think calling those things are not cases. Make sure that like a trivial test case afterwards. One, two dots. Did you delete that test case? You can do one better than us. Put an equal sign after 11 with certain equal to
I'll do that.
this isn't like some official syntax. It's just like eval that thing. What if we give it a soft max?
Then that makes sense. There's no elements map. No elements. Basically nothing happens.
The vector like yeah.
Or extra stability, you should also subtract them. You want to do that? I thought it was like, actually no, that I'm not think that it's actually yeah.
Maths is not that complicated. You're just like thinking slightly too much.
It is arbitrary.
It's not a line. You can do just like default. Default itself already has is a value. Just needs just add the type. You already have.
Oh, okay. So I just need help.
What constraint trigger? No.
Excitable. Oh,
Add ort as well. Does ort imply that, or is that just separate on top of that? I mean, you can add it. I've done this. It seems like that feels big of a constraint to me. I'm going to assume something different.
yeah. No, I agree.
Assume separate.
So, like, maybe the hypothesis or like,
Yeah. And what I usually do to get around the syntax error is going to give, instead of x and y, use the dot notation.
oh wait. Oh,
What's the three?
wow.
Oh, I think giving you this.
The done thing turns out I forgot to add that. Making it like it's like a lot of stuff to put in these stupid top bar, so I had to be a long. Oh wait, definitely some. Well, Do I even really need this? I don't think we need this. Let's keep max out of here because it looks like doing it in Java crashes and on. Let's just put max back here. So we can just do um, x dot over.
I just
Oh, we will just do. Oh, good.
actually it should be the max with negative 10.
So negative infinity. Yeah, I think like,
Negative float that in, but you need to put everything including the negative sign in parentheses.
okay. And then we do, yeah. Yeah, I think that's it. So the new local software. Wow, beautiful. So it's actually really like this like the doing on the logic we got maps off not just correct. We're doing over rows. It's not pushing so we should be doing the back. Yeah. These actually always do it. Like, oh, so we can return that's it. That's not baby. Yeah, because I didn't want to include the that kind of back. Just use the like a month shot. This is basically essentially iTorch's um built-in dot product engine function. No, that's yes. I think the bash one's more. Yeah, yeah. And you're gonna have a bunch of things.
If you add the notes, or you add the actual info for one extra thing.
Yeah. Which things is put as well. Oh no no no. Yeah, that's it. That's nice. It's actually very very.
You control I and just ask it to do it first, so we can do the right thing.
What what?
You can control I for both. Just say do it first. You know, like
Oh, um, there was no A. Why did you even ever put clause 3.5 in there? For real. I feel that I'm smarter than me. Uh, for now. And the problem is, I would use them more if they didn't just confuse. I think like I have a habit of getting confused. But if I just like try to accept how I'm supposed to don't understand, versus like, okay, I'm in charge. I'll just figure it out myself, and then if the LLM says something which matches my uh, intuition, then move shit up. Because otherwise, it just be a complete disaster. Uh, you you just need to backstop the standard way, you know. So one of them is going to be maximal backwards, which we are going to be paying for that. So basically just be like, there are different forwards, should be equals to coming close. Like, well, that's one thing that we're going to I think it's more. Um, I think it's yeah, that's what I did. I just spoke that. I already did. Let me do this. So, um, yeah, wait, surely there's like a infinity with sorry backwards. Up. But I mean, this is true. Actually, let's work it out first and let's verify because we do good exercise probably. Um, more that's nothing. I just spoke over the yeah, but it's going to be hard because what you have to do is at every point that you find the back like them up. That's the thing. I think I wish I got wrong. The wrong is this is really wrong. It's really the most easy thing. Most of the dollars. Wrong tablets, you know, like I went down to the packet level. I was like looking at this and trying to figure out where it's going. But it looks on all my other computers except for this one. This is what's supposed to be. When you have documents. And then so this is that. Now you want to get this is going to um yeah. The national independent. Check that. This softmax rows actually need anything other than maybe not trying how to do it. How do you know? Oh no, this is uh, oh god.
Wait, whose apple was that? It was by like where you were eating. Yes. Oh, it's yours? Oh, my bad. I didn't hear you. That's sick.
For this over annihilation.
You can also do the backwards calculation in there by composing a few existing backwards calculations. Just write it out in cases.
Yeah, we honestly could honestly like let's just do that. Yeah, let's do that.
But doing that by hand is difficult.
So
What's up?
not
You got,
much.
you got graded right now?
We're working on like trying to code GPT-2 in Lean. Heard of that?
And leave?
Yeah, Lean 4, the proof solving language.
How's it going?
It's honestly with where we're at now, it's not even like math based. It's literally just back the backwards path of attention. So it's just like a very simple exercise, which I was like, I guess you could find this online, but it's probably more educational to do it by hand just to refresh our memory. You know? I can't even know what it was to begin with. So
Like lean or
it's called LEA,
like the drink?
right? The beverage.
Are you guys math partners?
No, actually, I actually,
Or are you just doing stuff?
yeah, this is my side project.
Oh, I see. I see.
He's not even in that.
Oh, really? Okay. I don't know. I don't think we've met.
Oh,
They don't. Hello? Is this your keyboard?
No.
Geez, you got a lot of toys, huh? How does this work?
What's the like? Why? Is it just
I like
faster to type? It's supposed to like reduce like carpal tunnel as well. Which I don't. Wait, you said you like the what?
the thumb cluster.
Right. What is this for?
If you connect it with that,
Huh. Back to the coins. Like,
we can just do it.
so that's the only thing we have to. Let's just recompute the entire between the back. What's hey, what's up, Jack? Hey, where's the space bar? Okay. No, you have to the forward pass in the forward pass order, and then you'll go back and you'll remember if you look at remember that one autodidact paper it basically shows that in order to write a backwards class you need first forward computation and then you put the units from forward computation to do a backwards computation.
No, even this already.
Okay, so I do that. Yeah, we should name these time.
It's called an ancient. A bit triple prime.
Yeah, I think it's far.
Just really
I think it's far. I think it's so over here. Put the place of our W. So W is equal to yeah, yeah. Again, I actually said
yeah.
really that's the actual sigmoid.
But that's not the soft maximum. It's the sigmoid.
Yeah, let's implement sig. Let's implement or let's stub out.
That said, a sigmoid is a type of soft maximus property. Might go even.
I don't think so. I don't believe that. Surely they will remember how to use that software. Really? They're not a proof class.
Did not have an instance of stuff perhaps.
Uh, right now for fun, but later proving. I actually have.
It's kind of both. We have pretty simple proofs of some stuff. It's just that it's things like shape checking, which come for free, but are already really useful.
So basically, I think it's limited in what you can prove because of the ugliness of floats. So as you know, floats are horrible constructs which can't really be reasoned with. But you can maybe like start off with reals and then like do some nice terms with that, and then like say, okay, with floats you probably get an approximation of this, and that might be something you could prove. So the things that we're thinking about proving would probably be like results about like probably um, once we get like more proper algorithm here, you could probably prove some like things about the variance of like some residuals given like the variance of like previous residuals. It's doubtful we could get there, to be honest. Um, just like it is something people really want to pursue, but the fundamental issue is just that there's like a combinatorial explosion of like stuff that could happen. You know, like you could. I think the thing which I'm most excited to prove things like probabilistic stuff versus like proving something ever happens is so hard to do with like basically any amount of rigor. Just because of, sorry. Yeah, I mean, hopefully in the future. I guess right now we're just like laying down the groundwork, and then we'll figure out what we can do with it later. No, it's just a fun. What? How did I learn it? I did the natural number game. I actually never even did the natural number game. The way I did it was I was like, okay, let me write a let me write out like a vector in Lean because Lean didn't have any vectors. Like they had arrays but not vectors. So I was like, let me write a good vector implementation. I wrote a matrix implementation, and then I stopped working on it because it was getting addictive. Like I started like I didn't publish it because it's boring. It's like it's not interesting. It's just the implementations of stuff that people have already done. Oh, yeah. So you were treating it more as a yeah, basically. But even if you treat it as a programming language, you have to treat it as like a proof thing because in order to like even get certain like even to like do certain things, you need to prove things about it. Like for example, if you want to like I don't know index it already, you have to prove that your index is less than the length of the yeah.
Okay, but that's a bit misleading because you can just give a trivial proof or write an exclamation mark and then it will just check and fail at runtime if it's out of bounds. Like yeah.
Yeah, but I never used the.
You can also, instead of proving some function terminates, just write the word partial instead of partial depth. Partial depth instead of just depth, and then it's like fine.
Also, that lets you get around. Yeah, you can
Yeah.
use it as a programming language if you want to.
We're on a continuum of opinion of how much to use it as a pure programming language versus its more proof aspects.
Oh yeah, I've seen the
David
online
Ray
version.
Christensen's. Yeah. He was the director of the Haskell Foundation. He actually left.
Really?
Yeah.
That's so base.
Yeah.
What do you gain rise up?
I found this out because it was one of the top threads of all time on the Haskell subreddit of him while leaving
Nice.
for leaner pastures.
Wait, what's your name again? Nice to meet you. Sorry, I don't think I asked your name. Govind. Yes.
Oh look. ALOK.
Yeah. Why do you?
I find it faster. I like this one better. I learned it in one day. I couldn't even type before. This was the first keyboard I learned to type on. With 20. Like I can use the normal keyboard now. I taught myself that later. I think like okay, like 60, 70 words a minute. Not nearly as comfy as this spell.
What's your typing speed on this?
90. It's not like enormously faster, but it is noticeably more comfortable.
Yeah, I think my average typing speed on here.
Actually, more than typing speed, it's all the shortcuts I can use for window manipulation and stuff.
Oh, true.
Like you've seen me opening the splits and things.
Yeah.
But I've used it on those.
I can also do this. Called hyping.
Having it with the thumbs though,
Oh,
it's
yeah,
like
the
a nice
thumbs-
visual
The
vocabulary.
thumb stuff is great.
As you said, space key the greatest mistake. And you just sort of try to get, I can best a split space bar, but not even that.
I mean, like, which laptop even has this system? Like,
Check if you have an instance of the sun. When you were driving.
literally right here.
No, but that's not for vectors. It's just for the if they have a subsystem. It doesn't necessarily let unless you get better those different stuff. Here it's just things that stuff. We do like dot replicate stuff.
Oh, yeah, that makes sense. Um, oh, yeah, that's right.
Also, a nice trick might be to find a function that's like vector dot shape like, which will let you fill in some fill value, like zeros like one like.
Oh, yeah, let's call it just vector dot of. Like, we have of fun, we just call it of. Yes.
And you put it after of fun.
But I don't need to.
I can nice. But you're liking all function. That's the most classic function for the
But you can just say something instead of that. You can say something like, get, oh, oh, crud.
yeah. You have to get
Oh, yeah.
like a vector.
Sorry, it's already dot okay. Okay. It might not actually be wait, I'll just do that. Yeah. I don't even know if I could properly download it. Right? Proper software. Yeah. Yeah. Oh, okay.
It looks like it's essentially all the time.
Um,
Yeah.
the heck does this mean? It says np dot s s dot b. That gives me a single number. What's the key?
No, they don't fit it. Or just run it in the book.
But it won't tell me like an actual like function. Software. I'll say you go for Jack. Maybe Jack for actually that's a good idea. Yeah. Actually, I really do. Um, I haven't installed Jack. No software.
That's not gonna be. That's not- I was wondering if even after that you want to like only focus exponent, like just delete the one. But you on the other hand assigned it like mostly so that I can call it.
No, I knew that. I think because it's like that grad or something. No, this is probably not the right way to go. It'll probably be some criticism.
Like very well yeah.
No, it will. It will show me like the operations, but like there's like a thing for, but I'm just not sure it'll be interpretable.
If you on stores, maybe it would get different. Probably not.
No, wait, don't you remember how Jax works?
Call buying.
No, but I was gonna say like the backwards it's like determined like by the grad function. The grad function doesn't even have a backwards really speaking. Like like automatically construct it backwards at grad time by like doing that whole linearization process. Taking like transfer. Mhm. Okay. Let me just go in. And wait. Really different. Maybe this find somebody like who just walks through experts and show me.
Oh, nice.
I think we can just look at it as a black box for now. You do have to test this out sooner rather than later. I think next time, the basic, I kind of want to get back to my show of vibe. So after Wednesday, because I do the third time, but on Wednesday or Thursday or Friday. Actually, so you know what I'm saying? They're trying to get softer. Since I think it's bite size. What?
Which one do when you said let's get off?
Oh,
It's like it's not a back.
back. This is what GitHub says. Like, we're going to look at some softmax examples and we like, oh, huge. Oh,
we wanted to
Yeah, it's kind of hard. Um, so I think we just like simplify. We want to go well. Oh, okay. So this is soft math. You said you read it and it was good.
It's just basically the same as that counts.
But like he just does a soft math.
Wait, but other stuff wouldn't.
Like look over here, it's soft math plus loss.
Yeah, this one is mixed with fun.
Yeah, but you just want soft math together.
Yeah, but he gives just softness in there. It's a substitute.
You do.
Right there. DPJ by OI, those two lines.
But this is wrong. So how is this?
It says that
Like,
this guy,
do you know if he went wrong here or later?
Wait, look. So derivatives PAOI are correct, but there's an error when you add on L. So we had log of the
Let's read this.
compute the derivative of the space that so soft
Fine. Yeah. We want the vector. We want the each input with regards to one law. Oh, so that's what it was. I guess that's the explanation. softmax at any.
I think what it is like nicer formulation. The one.
No, I don't think so. This so one not like the thing we want to do is if I equals j if when I usually computing like for any given term we want to compute it for like the entire vector, but it doesn't make sense. Like we haven't selected a vector to take a derivative of. We are only want to like given like a list of derivatives, we want to like find it out for all of them. So we somehow need to like distribute this data somehow. Like, and it's probably okay. So I like we shouldn't be doing a full Jacobian because that's not what we want. Obviously, we have like some softmax like we have softmax. So, and that gives us like some value like y, and then some function y, like f of y, we can give us some so, we want to know what is x maybe equals yeah, multiplied by 5 and softmax yeah. Sorry, but we saw I guess it's just notation for like softmax x, you know. But rather softmax like to be like dy over dx.
Over dx over d soft. Those
No, I was abbreviating abbreviated wrong. I hope that makes sense now. Basically, what I was trying to do was I was trying to like, oh yeah, because it's listening to softmax x over dx, maybe I can just write d softmax. But then I was like, oh no, that doesn't matter.
also, don't we really want the from with respect to
Remember, cancel, cancel. Yeah, yeah, over dx automatic.
No, I'm saying that on the left hand side when it says dx dl,
You mean
don't we want
this side?
yeah, don't we want that to be dl the sensitivity of the loss to a change.
We're saying okay. We wiggle the loss a little bit. How does that change does that change the x? That's what we care about in the backward path. It will be 4 differentiation if we were like, okay, wiggle the x a little bit, how much is the loss change? We could calculate that purely through using rule numbers.
This one on the paper.
No, it wasn't in, that's not in the paper. This is just like I think this was inside autodidact or like one of the things related when we talked about autodidact. It wasn't, or maybe it's in the paper but implicitly. Basically, just think about it for a second, right? So inside the backward pass, we have looking at one output in specific, and we want to figure out like the changes of all variables that contribute to the output. Versus it's a forward mode, we're looking at one input and we see all the different outputs that like see how all the different outputs change. One is interest, one is extension.
Like they just seem forward and backward mode, and the advantages of both is pretty clear. That if you have more outputs than inputs, you want forward mode,
Exactly.
and vice versa. That's pretty no weird. The, and even here, it's that given in a backwards pass, we still would be perturbing something, which is why like looking DL over DX instead of DX over DL.
Oh, wait, so can you repeat that for a second? I didn't catch it.
Though we would still be perturbing some input.
You're trying to see the output.
Yeah, the sensitivity of the output to the inputs, which would still be DL
So-
over DL.
So I start out with with a gradient, right? I start with a gradient that I want to apply to, right? I'm saying, okay, change the loss, like this is the change I want to make to the output. And then that translates a change in like all of the input variables. Like the W or the DX. This is fine. Versus if I was going the other way, then I had to pick what change I wanted to make already to the matrix. Making sense. So start from the other direction.
Yeah.
Don't worry about it. You have no idea how many times I've run into these problems. Just like all the time. Ridiculous. Yeah.
Now this expression. Yeah, right. Y by DX.
I think I'm just gonna do this long.
Can you push this down?
Yes. I'll take a screenshot. Yeah, the same.
You were looking. Yeah. But then I wasn't that light enough to make one. I turned around after it. And then I like, wow, like first of all, I don't have to know it. But even if I went like, I look at it now, I still
That's fine.
You know, we could use the multiplication sign for that call, and it would have worked for just the one for like without having to implement the damn big thing. Because we could limit the instance to remove vectors of vectors.
Yeah, we could have done something like that. I mean, and we could also do like something kind of like thing again, like circle dot. Yeah, something like that. Anyway, good session. What are you doing in the meeting? I said, what are you gonna go over?
Just go. Going over it in the science.
Oh, yeah, yeah. I do really need to figure out how. I need to get better with the Jacobians. I feel like I don't really understand it that well, which is amazing. No, I mean like I feel like I understand the general concept pretty well, but like how does that like both like Jax and like basically everything over here like uses like certain simplification Jacobian to be like, oh yeah, actually when you think about it, you're just multiplying by the Jacobian. It's like a JVP, right? Jacobian vector product or something, or like a vector. And that's the stuff which is like I feel like I don't understand that stuff. What they do in a soft max as well. Like they're like, oh yeah, so you're in soft max, you can multiply it out to get something that we want. And I'm like, oh, that's
Not interpreting something with the
yeah, this is more of a
whenever I hear people say something about
Jacobian product. Say this. Yeah, that's also true.
Well, they both examples of what are called pullbacks.
A pullback, I don't even know what it means, so I need to look that up as well.
But it's the general concept, and it might be what we actually need, since we might in general intensity. At least that's transpose the
Pullback, just like a linear map. Maybe more complex.
The short one is that it's one that makes this complete this in real time. Goes back in the final pull back too, but
Gotcha.
that's not super helpful.
That makes sense, I guess.
Tables are pushed forward.
I understand the duals in terms of like the natural weapons, and like
Like lots of things are pullbacks. Like here's a pullback actually. You can pull back the distance or click onto sentences by taking some word embedding, and now each sentence is mapped to some vector. And now I can use the distance function that's defined on vectors to define distance between words. So I'm pulling back the distance function along this embedding function. Transfer structure onto the word space.
I will look at this game and we'll get back to you next time we do some. Yeah, because my brain is kind of like I know what you You know my other hobby project actually, which I haven't really started yet, but I'm starting soon. It's to make a transition parser for words. Because I want to make a like right now I've looked online. There's space and there's Coronel Three, and there's like a bunch of other none of them run on the web. So I want to make a JavaScript framework that runs on the web. And allows you to like segment sentences just as client side library. Which is actually not that fun. It's just like it's just gonna require you to like learn a little bit how like create a simple transition parser model and then port it to Onyx and then write some stuff in JavaScript that will make that Onyx work write it on the web and then deploy it to the library and then rake in the stars. Yeah, but wronging?
Yeah.
You never heard that?
You never heard the word thronging?
Never heard that.
Sound.
Sounds disgusting.
Well, so are the unwashed masses when they're all thronged together.
Yeah.
Adios.
Actually, I'll be back because I just realized I can throw away this thing and do it.
It's not like specifically computing like what is the best possible thing. It's not easy that. Are you either green or weird? I had a choice. I would make it awesome. And I think it would be.
You're alive. Right. I made it. I bought it. You know, oh, well, I'll tell it again. Again. Yeah. Right. Only relative why or just well, you know, I don't know. And I went down with them. It's right. Paid a full $55. I call that value. Yeah. And then I should have like well, like the thing is on the original contractual you know, we'll probably get back to 4 or 5 we'll probably beat up. Man, am I really waiting around 2 hours? I don't think so. Like, what if they like went down the hill the wrong side? And then like I'm like people like they're having fuck. Not really. You just surprised I didn't. You want to rather life? Another day. Another day. Yeah. Are you working? I told you. Oh, okay. I thought it was years. Decades. Years. Okay. That's still good. Kind of weird. Like anything that's not ethically done is part of 0.9 years, 0.1 years, 1.2 years, 1 year. Yeah. Well, 1 year and 0.6.
like you can right? But it's also definitely more expensive. But like, oh, it's good to go once a year.
I do have a little, I didn't see anything about it.
Yeah, I don't have
Okay.